Good evening. So today our group 3 will be presenting about the potential of pomegranate as an initial indicator. Our group members are Mahin, Farheen, Cheryl, Arina, and Rishika. My name is Mahin Ibrahim, and I will be presenting a brief introduction about what pH is and what a pH indicator is, and also I'll be giving some examples of indicators. pH is the measure of how acidic or basic a solution is by the amount of free hydrogen and hydroxyl ions present. The scale goes from 0 to 14, with 7 being neutral. A pH between 0 to 7 means the solution is acidic, while 7 to 14 means the solution is alkaline. To find out the pH of solutions, indicators that change color according to pH are used. Examples of indicators include phenolphthalein, methyl orange, methyl red, thymol blue, and pH test papers, which is litmus papers. Red litmus paper turns blue in alkaline solutions, and blue litmus paper turns red in acidic solutions. In this picture, we can see that the red litmus paper is turning blue, so that means that this solution is alkaline. pH meters are also used to find out the pH of a solution by measuring the electrical potential difference between the pH electrode and a reference electrode. Natural indicators are substances that can be found in nature which determine the pH of solutions. Examples include beetroot, hydrangea flowers, cherries, red cabbage, and turmeric. The color of beet juice can be changed from red to purple in a very alkaline solution. Numerous researches were conducted for various extracts on their potential to be used as natural indicators. It was found that natural plant extracts perform best in strong acid and strong base titrations. The sharp contrast between their colors makes them suitable for use as acid-base indicators. The drawback of using natural plant extracts as indicators is that they need to be prepared fresh, as they are susceptible to fungal growth.
Hello everyone, I'm Farheen and today I'm going to be talking about the literature review that we have prepared for this experiment. Prior studies have shown that the fruit Punica granatum, pomegranate, presents a high content of anthocyanins, which are basic organic substances and have a protonated version. Among the main properties of anthocyanins are that their diversity of colors makes them possible pH indicators. In acid-base titrations, indicators are used to show a sharp color change at intervals of pH. Natural pigments in plants are highly colored substances and may show color changes with variations of pH.
Thank you, Farhin. Hello, everyone. I'm Cheryl Nicole Hendricks. So to continue on what Farhin had just presented, herbal indicators are more advantageous than synthetic indicators. Herbal indicators, they give a sharp and better color than indicators such as methyl orange and phenolphthalein. They are also environmentally friendly as compared to synthetic indicators that would cause pollution. Also, they are cost-effective and they can be obtained easily, whereas synthetic indicators, they are produced after various chemical processes and they cannot be extracted easily from raw materials like fruits and vegetables. Many other plants have also been observed to be better pH indicators than synthetic indicators.
Thank you, Cheryl. An attempt was made to investigate the indicator activity of methanolic fruit extract of Punica granatum and to replace the synthetic indicators in this experiment. This methanolic fruit extract of Punica granatum from family Punicaceae gives sharp and intense color changes as compared to phenolphthalein, methyl red, and phenol red. The indicator was evaluated using strong acid, strong base, strong acid, weak acid, strong base, and weak acid, weak base titrations. In all these titrations, it was observed that the indicator was accurate and useful as a pH indicator. Acid-base titrations are used in the determination of the concentration of an acid or base by exactly neutralizing the acid base with an acid or base of known concentration. This allows for quantitative analysis of the concentration of an unknown acid or base solution. Acid-base indicators are used to signal the end of acid-base titrations. The sharp contrast between their colors in acid and base makes the pigment suitable for use as acid-base indicators. As these herbal extracts have very simple Cost-effective, environmental-friendly extraction procedures, and excellent performance with sharp color change and endpoints of titrations, it would be possible to replace the standard indicators being used in conventional laboratories with natural herbal indicators. Now I will pass on to Cheryl to continue further.
Thank you, Farhin. Okay, back to the slide. The screening was performed with 3 different molar strengths of acid and alkalis, which are 0.1, 0.5, and also 1 molarity. Why 3 different molar strengths? Well, as we all know, an acid is any species that increases the concentration of hydrogen ions, and a base increases the concentration of hydroxide ions. Therefore, pH of fruit extract depends on the acid and alkaline molar strength. So, for example, if there is higher concentration of hydrogen ions compared to hydroxide ions, the pH value would be less than 7, which means that it is an acid. Contrastingly, the pH value will be more than 7 if the concentration of hydroxide ion is more than the concentration of hydrogen ions, which means that it is a base.
Hi, I'm Rishika here. I will be continuing with the problem statement. Nature indicator is also a type of indicator that can be obtained naturally and used to identify whether the substance is an acidic substance or a basic substance. The reasons looking for the replacement of pH indicator using the nature pH indicator are that the nature indicator are easily available from our nearby grocery stores or supermarkets, and could be easily extracted from raw materials such as fruits, vegetables, and flowers. Moreover, nature indicators are also cost-effective and environmental friendly, whereas synthetic pH indicators are more costly, and it also causes environmental pollution, which is due to chemical hazards.
I'm Arina, and I will continue with the objective of the research. The first objective is to examine the efficiency of the nature indicator. Next, to investigate the pomegranate can identify the acid and base solution. Lastly, to identify the color changes in acid and base solution.
Hi, I'm Rishika here again. I will be continuing with the materials and equipment needed in this experiment, which are punica granatum, which is known as pomegranate, methanol, dilute hydrochloric acid, weight machine, measuring cylinder, beaker, glass jar, clean cloth, knife, cutting board, milk, lemon juice, baking soda, detergent, filter funnel, filter paper, conical flask, and water. So these all are we going to use in our experiment. Plant selection of this experiment is punica granatum, which is also known as pomegranate. So as you can see in the picture, this is the pomegranate. This experiment will be conducted through aqueous extraction method using alcohol, where the pomegranate maturated in a solution containing methanol and dilute hydrochloric acid. Let's continue with the method of extraction to prepare the fruit extract. Firstly, we have to buy the fresh punica granatum pomegranate fruit from the local grocery store. Don't forget to wash the pomegranate fruit and wipe it with a clean cloth. The third step, we need to cut the pomegranate into small pieces using a knife. Then measure 100 grams of small pomegranate pieces using weight machine and place it in a glass jar. The fifth step, we have to measure 135 ml of methanol using a measuring cylinder and pour it into a beaker. Then measure 15 ml of dilute hydrochloric acid and pour it into the same beaker to form a solution. So in total, you will get 150 ml of solution. The sixth step of the method of extraction, we need to pour the solution into a glass jar containing pomegranate pieces. Then, macerate the pomegranate pieces with 150 ml of solution containing methanol and dilute hydrochloric acid for 3 hours. Make sure to close the jar tightly with a lid to preserve the extract. We must store the glass jar away from the direct sunlight. After 3 hours, filter the pomegranate extract using filter paper. The pomegranate extract is the nature indicator.
Next slide is the production of pH indicator. In this experiment, we will be used 5 different types of liquids under the category of acid, base, and neutral solutions. The extract of the pomegranate is the indicator that will be used in the experiment. Pour the pomegranate extract into 5 different beakers and mix each liquid into the beakers by placing several drops. Then mix the mixture of the pomegranate and the liquid and wait for a few minutes for the changes of the color. Next slide is analysis and the test of indicator. The indicator will be tested by using neutral, acid, base solution, and all the liquids that will be used in the experiment will have a different pH. The color changes of the mixture indicates the result by referring the pH scale 1 to 14. 1 to 6 indicates acidic, 7 is neutral, and 8 to 14 is alkaline. Figure 1 shows the pH of level of each solution used in the experiment. In this experiment, we will use 2 different acidic solutions, which is lemon juice with the pH of 2 and milk with the pH of 6.7 to 6.9. Neutral solution, which is water with the pH of 7, and there are 2 different alkaline solutions, which is detergent with the pH of 10 and baking soda with the pH of 8. Next is the expected result. Figure 2 shows the expected result of the color changes of the solution. First is lemon juice, or expect to change the pomegranate extract, which is the indicator, to dark pink or red, which indicates the lemon juice are strong acid. Next is milk. The expected color changes are light pink, which indicates milk is weak acid. For water, there is no color changes as the indicator will remain pomegranate color, and the result in neutral pH. Baking soda were expected to change the color of indicator to light violet or light blue, and that indicates a weak base. Lastly, detergent are expected to change the color of the indicator to blue or violet, which indicates detergent are strong base solution.
In conclusion, the titration evaluation showed that the fruit extract of pomegranate was precise and had a sharp color change from pink to colorless in alkaline solution. Its performance as an indicator was also compared to standard acid-base indicators like methyl orange and phenolphthalein, and it gave a sharper color change. Its use in weak acid and weak base was found to be more significant over standard indicators as it gives sharp color change in a narrow pH range. It was proven to be more simple, economically benefiting, easier to prepare, environmentally friendly, and also gave more accurate results. And these are the references that we use to prepare the slides. And that's it for the presentation. Thank you for listening.